Okay, so today we're going to start vectors. So let's start out with a definition. So a vector, okay, is a mathematical term that indicates both direction and magnitude. If you've seen Despicable Me, this should sound familiar. So indicates magnitude and direction. Okay, so the easiest way to think about magnitude, now lots of things are vectors. So velocity is considered a vector. Okay, all right, so I ran at a 5 mile per hour pace due east. That would be a vector. Okay. Um, Acceleration is considered a vector. Displacement is considered a vector. Force is a vector. If you're in physics, this should be exceedingly familiar. Okay, so we have different ways to say vector. So the first way to indicate a vector is by points. Okay, so the first point is your initial point. So we'll call that P, and we'll just say that's 2, 5. Okay, and then your final point or your terminal point, which is where you end, okay, is Q. We'll say that is, I don't know, 10, 18. Okay, so that would be if I were to put a vector on any place on my coordinate plane. So the initial point is always listed first. Okay, and then the terminal point is always listed last. Okay, all right. Now, so what we do is sometimes what we do is we take a vector and we move it to an easier position to calculate with. This way is called component form. Now, with component form, the initial point is always 0, 0. Okay, the terminal point is where it ends up, and it's the only information that you're given. Okay, so component form is written like this. So we use kind of a triangular bracket. Okay, so this is exactly like a point. X is first, Y is second. But we are, since it's notated like that, we know that it's a vector with an initial point of 0, 0. So if I told you I have a vector of 4, -2, Okay, so that's my vector. So what you would do, if you wanted to know what that vector looked like, whoops, okay, is you would say, well, okay, so we're going to count out. Let me move that so it's a little bit better. There we go. All right, so we're going to go 1, 2, 3, 4, and then down 2, -2. So my vector would start at 0, 0 and end at 4, -2. Okay, let's do another one. Let's do -10 and then 7. Okay, so to graph that vector, okay, you'd find -10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then go up 7. So that would be your vector right here. Like that. So this is the vector 4, -2, and this is the vector -10, 7. Okay? All right. So let's talk about having points and then going to component form. So basically what you're doing is you're moving the vector to an initial point of 0, 0. So let's say I give you a vector that has points 3, 10 and -4, 8. Okay, so that's your vector. Okay, your initial point is 3, 10. Your terminal point is -5, 8. So all you have to do is subtract. Now, like slope, order matters. Okay, we always want our terminal point minus the initial point. So we want to go terminal minus initial. So we're going to go -4 minus 3, and then 8 minus 10. And that's going to give us our component form, -7, -2. Okay, so the formula is if you are familiar with the slope formula, this is pretty much the same thing, but you have to start with that terminal, then minus the initial. Okay? Let's try another one. Let's say your vector is given by initial point R, terminal point S. Okay? So we're going to write our new vector. We're going to use our formula. So we're going to go -8 minus a -10, and then a -13 minus a 12. So then we have 2 and then -25. And then we're done. Okay, so remember, if you are written in component form, your initial point is automatically 0, 0. Okay, so let's talk about magnitude and direction. Okay, and then in the next video, we'll talk about something called scalar multiplication. Okay, so a magnitude of a vector is or can be considered its length. Okay, so how long is it? All right, so how we find the length of the vector, okay, if you're in point notation, you're basically going to use the distance formula. Okay, so distance formula looks like this. I forgot my squares. Okay, now if you're in component form, things get a little easier, but the notation is a little new. So if we have a vector v given by the component form a, b, like that, okay, if we want to find its magnitude, so you'll find a what looks like a double absolute value, okay, and then you're going to take the square root, and it's going to be a squared plus b squared, okay. This is simply the distance formula, okay, but your x1 and y1 are 0, 0, okay. So let's try one out. So if I have the vector v, and it is -8, -10, and I wanted to find its magnitude, okay, so I'd go -8 squared plus -10 squared. That would be 64 plus 100 square root, and then the square root of 164 is 2 square root 41, or approximately 12.806. Okay, so that's how you find the magnitude of a vector. Okay, so how long it is. Okay, so remember, a vector is magnitude and direction. So let's talk about direction. Okay, so you'll notice that a lot of this stuff kind of looks familiar. Okay, all right, direction is going to be an angle measured from the horizontal positive axis, okay, if you are in standard position. Okay, all right, so let's say my vector is this guy right here. So that's vector v. My direction angle will start here at the positive horizontal and go counterclockwise. Look familiar? Okay. So, a couple of notes. One, you have to be aware of what quadrant your angle lives in. Okay, because if you're going to use your calculator, remember, if you use tangent inverse or cosine inverse or sine inverse on a calculator, it limits the answer to just two quadrants. So if you're living in a quadrant the calculator doesn't like for the inverse, then you're going to have to adjust. Okay, so the formula that is typically used is tangent b over a. Okay, so depending on what quadrant you're in, okay, if you're in quadrant 1, everything is fine, you don't have to do anything. This is if you're using your calculator. Okay, if you're in quadrant 2, okay, and you're using your calculator, calculator is going to give you a negative angle. So you're going to have to add 180. Okay? If in quadrant 3, okay, so if your angle lives here, okay, the calculator is going to spit out an angle that actually lives in quadrant 1, so you're going to have to add or subtract 180 depending on which way you want to go. So again, add 180. Okay, and then if you're in quadrant 4, you're going to have to add 360 because the calculator is going to spit out a negative angle. Okay, so let's try this out. Let's find some direction angles. Okay, remember your theta is measured in a counterclockwise direction from your horizontal axis. So what we're going to do is I'm going to draw a couple of these. Okay. All right. So my first vector, we'll say it's -5, -7. Okay. And my second vector, we'll say it is +8, -5. Okay, so I am going to have to use my calculator now. With vectors, we typically use degrees. Okay, so first thing I like to do when I do this, okay, is I like pictures. I don't like just using straight formulas. So I'm going to graph my vector, just make a quick sketch. So -5, -7. About right here. Okay, so theta is this guy, right? So what I'm going to do is I'm going to draw my triangle like I normally do. -5, -7. And I'm going to use tangent theta. Okay. -7/5. Now I'm going to use my calculator. And find theta using the tangent inverse. Okay, so type that in. Okay, so my calculator kicks out a 54.46 degrees. But that angle, okay, That's in quadrant 1, and I don't want that angle, okay? I want to be in quadrant 3. So since I want to be in quadrant 3, I'm going to add 180, and that will give me my true theta of 234.46 degrees, okay? So you want to make sure that the angle reflects where your vector lives, okay? So that's my final answer. Okay, let's try this one. Okay, I have 8 and then negative 5. So 1, 2, 3, 4, 5, 6, 7, 8, 3, and 5. There's my vector. Okay, I'm going to draw my triangle. So 8, negative 5. Notice I'm in quadrant 4 now. This one I was in quadrant 3. Okay, so tangent theta is negative 5 over 8. To find theta, we're going to use the tangent inverse. Again, we're using the calculator. Okay. Okay, and the calculator will spit out a negative 32 degrees, 0.01. Okay, now I don't really want that negative degree. I would like it in positive. So what I'm going to do, now sometimes negative angles are okay with this. It kind of depends on what you're doing. Okay, but another answer would be 327.99 degrees. Okay, all right, so the next video we're going to do is we're going to do what's called a scalar multiplication and see how that affects the vector. Okay.